Okay, so we were discussing target DSA test T4. We have already discussed uh, problem 1, problem 2, and problem 4. This is the problem 3, prime safe node assignment in trees. This is actually originally from Google OA, problem 2 in some set, I guess. Okay, without wasting much time, let's get started with the problem. In this problem, what we are given as uh, you are given undirected tree, okay, with n nodes. Nodes are numbered from 1 to n, and you are having n minus 1 edges. Okay, normal tree uh, structure is given. Tree is rooted at node 1. Okay, so the tree is something like this. Can have any number of children, but the tree is rooted at 1, which is fixed. Okay, what we have to do, your task is to assign a prime number selected from this range to 200. If you don't know uh, from 2 to 100, there are 25 number of prime numbers. You can verify also. Uh, yeah, I have enlisted those numbers. So I have to assign each node a value which is a prime number. Okay, and there is a constraint also for any two adjacent nodes u and v. The sum of values assigned to u and the value assigned to v, that sum should be non-prime. Okay, determine the total number of such valid arrangements of prime numbers, and I need to output the answer after taking modulo with 1 plus 7. Okay, no problem. So the number of nodes is 10 to the power 4. Okay, so the given tree will look like this, something like this. So let's quickly note down all the prime numbers which are occurring from 2 to 100. There are 25 number of prime numbers. These are 2, 3, 5, 7, 11, 13, 17, 9, goes on up to 97. What you can. Okay, let's take a general example. Let's say if this is the given tree, and let's say initially I have assigned 2 to node 1, right? Then in that case, uh, I can assign what value to 2. Let's say if I am assigning 3, 2 plus 3 is 5. This will not work. Let's say if I assign 5 to this node, again I will get 7, which is a prime number. Let's say if I assign 7 to this number, then it makes sense, and then it is a valid assignment. But there is a case. Let's say I have assigned 2 to node 1, then 7 to node 2. Let's say I can assign 7 to this and 7 to this as well, and something else also. Let's say can assign, you can say, yeah, 13 also. And okay, let's say I have assigned 2 to 1 and 7 to node 2, right? Then I just, if I'm done with this part. After this step, like, there is no need to consider this edge. Just I need to take into consideration is this subtree, which is rooted at 2, right? Again, this subtree which is rooted at 2, right? I have to assign prime numbers to this. I have already assigned to this, and this. I have to assign prime numbers to these nodes, right? If this node is assigned to 7, I'm talking about 2, then I have to assign all this stuff. But let's take another case. When I have assigned uh, 5 to this node, then again also I can assign 7 to 2, because 5 plus 7 is 12, which is not prime. In that case also, I need to consider this subtree where 2 is assigned as 7, and I need to find the valid number of arrangements. If you are able to see, like, that's how you can see the overlapping subproblems in this particular problem. For 2, when I have assigned 2 to this node, then also I have to calculate for this subtree where I am assigning 7 to 2. And if I am assigning 5 to 1, then also I have to calculate the number of ways of arrangement when I am assigning 7 to 2. Why should, like, why to calculate this sub problem again and again? This is the case where we can use dynamic programming to compute the overlapping subproblem only once and use the result of that subproblem again and again, right? So after this part, we are clear that we have to use dynamic programming from this problem. Let's try to make a DP state. Okay, let's say I am just trying. Let's say I have tried DP state something like this. Like DP of u comma I is the number of ways to assign prime numbers to all the nodes in subtree rooted at u, such I have assigned ith prime number, ith from this. If let's say this is the array, then ith prime number to u. If this is the DP state, then DP of u comma I is the total number of ways to assign the prime numbers to all the nodes in this subtree. Basically, if this is the u, these are v1, v2, and all these nodes, this is your tree, you can say. If I have assigned ith prime pi to this u, then total number of ways to assign all the nodes a prime number is stored in this DP state. If we are clear with the DP state, let's move to the transition part now. Okay, I need to find the total number of valid assignments, right? If I have assigned ith prime to u, because I am calculating DP of u comma I, so I have already fixed the I. So for all its children, let's say for each children, let's say I'm right now talking about some random v. Let's say there is a edge from u to v. Then in that case, for v, I can assign any prime number from like p0 to p24, because there are 25 prime numbers from 2 to 100, right? So let's consider that. Let's say if I this is the edge from u to v, I have assigned u as prime pi and pj to v. Then from for this to be a valid assignment, uh, pi plus pj should not be a prime number, right? Not prime. This should be the case. Okay, so we have to try, we have to see these conditions to build DP transition. So if I am currently at u, I have to go to v, and for v I need to check for each jth prime whether I can assign that jth prime with this edge between u and v where u is already having the ith prime or not. Okay, if I have already fixed u, then number of ways of assignment is basically the number of ways of assignment of all the children individually, summation of these. This is simple DP stuff, I guess. So the transition will look like something like this. This will make more sense when I will show you the cursive code. This is that condition for transition. So finally, okay, so this, if this was the DP state, then the final answer to the problem should be overall the whole tree is this only, right? So I need to so the final answer should contain DP of 1, and I can assign any prime to this, right? Because DP of 1 comma some I is the number of ways to assign prime numbers to all the nodes in this tree, such that I have assigned ith prime to 1, but I can be anything, so I have to consider all the prime numbers, the contribution of all the prime numbers for this. So the final answer should be summation of 0 to, yeah, it should be 24, because there are 25 prime numbers. this should be the final answer for this. So the overall time complexity and space complexity I will discuss after the coding part. Let's quickly see its code now. I've already coded this problem. Okay. So input format is this. I am having my n, the number of nodes, then I am having u and v as edges. Okay. So initially, yeah, first of all, I need prime numbers as well from 2 to 100. And you all know how to find the prime numbers from 1 to some n. 1 to n is simply 2 to n only because 1 is neither prime nor composite number. So for this part, I have used sieve of Eratosthenes, which is a standard algorithm. Eratos, sieve of Eratosthenes. I guess this is something. Sieve of Eratosthenes. This is the spelling of this algorithm. So you can find sieve of Eratosthenes at CP algorithm. I guess I have already somewhere in some of my previous video shared the link. No problem. I will again share it with you in description box. So this is my vector is prime. I have just implemented the C of Eratosthenes. Initially, I have resized the error as n plus 1. Is prime of 0 and 1 I have updated by 0. Then this is just standard sieve stuff. Then I have iterated from 2 to n. If the number is prime, I have pushed that number to the prime array and I have returned the vector. Okay, I have already created this check prime function, which is just checking whether a number n is prime or not in the okay, so I have my prime vector which is containing these number 2, 3, 5, 7 goes on to 97. Okay, so after this I have taken n as input, the number of nodes. I have created the adjacency list of n plus 1 size. Then I have considered these n minus 1 edges, created the undirected edge. Then then I have created 2D DP of n plus 1 comma 25 size. 25 for 25 primes and n plus 1 for 1 based indexing because the nodes are from 1 to n. Okay. So where dp of u comma I is again the number of combination that I can have in subtree of u if I am assigning I is prime to u. Similar. One thing should uh, use as a rule of thumb. Uh, Whenever you see a dp problem, in tree, mostly or you can say 90% of time it uses DFS. And using DFS function, uh, simple recursive DFS, you need to update your DP states, and we will see how it runs. Okay, when I am currently at U, basically this is simple DFS on tree. I am having my U, the current node, and the parent node from where I reach that node as the parameters. This is just a lambda function. You can implement the DFS function normally as well. Lambda function is used to basically implement the function inside the main function or any nesting functioning basically you can say. This is used to avoid the unnecessary parameters which we generally pass inside the function. Okay, so return type is void. Let's say if currently I am sorry standing at u, I have initialized the dp of u comma 1 as 1 because there is only one way to assign that initially. Then I have to explore for all the children of that particular node. For auto v belongs to adjacency list of u. If v is equals to parent, that means uh, uh, I have already explored that element. So just continue. Otherwise, just call DFS of v comma u. By calling this DFS of v comma u, you can directly imagine, or you can say that DFS, the recursive function, will handle all the DP uh, thing for the V. You just have to find, you just have to update the DP state for you. Okay, after this DFS part, DP state of V comma all the J's are already calculated. That's how the recursion works. Okay, so you can assign for each I you are assigning to you are calculating the uh, number of ways to, yeah, I guess I have it. Second. Oh, wait a second. Oh, sorry. Yeah. When I was at this part, yeah, I guess I have by mistake I said if you are having U and various V's, you have to calculate the answer for individual this part and then multiply with all these parts, because to have a valid arrangement, number of ways to have this multiplied by number of ways to have this multiplied by this, simple PNC. I guess at that time I have by mistaken said plus operation, but this should be product. Okay, so yeah, for each I to be assigned to U, I have to check for all V, right? All J's. If I'm just checking whether the is prime and j's prime are having their sum as prime number or not. If this is not prime, that means I'm having a valid uh, assignment. Answer I have to update by dp of v comma j. This is just a modular arithmetic part. And then when I have already uh, yeah, when I have already covered all the j's, for all the j's, that basically when I have already covered the contribution of that particular that particular child for all the j's, I am having my dpo, I am having this answer which is currently storing this part. If this is something u v1 v2 v3 something, let's say after dfs I have called the dfs for this node, then the answer at this step is storing the number of ways for this part, this whole part, which I need to like take product with dp of u comma I, right? For all these. Okay. So that's why I've done this dp of u comma I multiplied by answer and then just modular part. After this DFS function, implementing this DFS function, I have called this DFS function for one. After calling for one, I am having my DP array completely filled, and the final problem, sub problem is summation of DP1 and I, which I have already discussed. So that's how I have returned the, I have printed the output. Let's quickly do, yeah, run this code. Code, it's running. See whether all the test cases are passing or not. All the test cases are passed. Okay. So I was saying, yeah, I was talking about time complexity, right? So the sieve itself takes something big of, yeah, it takes big of time complexity, somewhat uh, root n, square root of n log n, something like this, I guess, which is if you can say almost big of square root of n in vague terms. This is square root of n. Again, this is also square root of n. Okay, so this is big of n plus square. I mean, almost up to this step, we are having time complexity of big of n, and after this step, DFS is just linear. So time complexity of DFS function is always big of n. But this is not n only. This should be n, but still 25 multiplied by 25. It should be 25 square times n, I guess. Yeah. So overall, the time complexity for this problem is, in vague terms, you can say big O of n times 25 square. The n for the problem is this, so this will not be a problem. That's all for this problem. Let's quickly re-summarize the problem. Basically, there was a rooted tree which is rooted at 1. We have noticed that there is a case of overlapping subproblem, so we have considered DP, and in DP we have built DP state as DP of u comma I, where DP of u comma I is storing the number of ways to assign prime numbers to all the nodes in subtree of u rooted at u. Basically, I'm talking about this, and anything can be, but currently I'm talking about this subtree, right? So transition is this only. I will calculate the temporary answer for one particular path, where for that part I need to consider all the contribution of all the j's, dp of v comma j's, and then for each branch, for each branch of tree, yeah, for each branch of tree, like these I need to product the answer. I need to take the product of answer, which I have taken in this step. Then just modulo part, call the DFS for 1, because 1 is the node in 1 is the root of the tree. That means the dp of 1 and some prime number means I am considering the tree rooted at 1. That means I have considered all the nodes, and then just the calculation of answer. I guess that's all for this problem. If you are having any kind of doubt, you can ask in LGOLH discussion group. Yeah. Bye bye.